Okay, so in this lesson, this is our final lesson in our volume section. So we looked at the standard ways we calculate volume, the things that you learned when you were in junior high, high school. Then we took a look at some specific examples in the last lesson for how to use those principles to calculate the volume of concrete required for a foundation footing and foundation walls. And we learned about centerline perimeter. And now we're at our final lesson where we're going to look at how do we calculate the volume of concrete needed for a floor. And then after this lesson, you'll have an assessment to do. So we're going to go through some examples. Please take the time to watch the video through. I'm going to do an easy example to start. Then I'm going to go through a couple of examples that are commonly have errors. So I do really want you to follow through the examples and at least catch those highlights of errors that people commonly make so that you don't make them when it comes time for your assessment or your quiz. All right, so let's get a visual just in case you haven't seen concrete being poured. Kind of get a visual of what it looks like. So at the time when you're putting the floor in place, once we're putting the floor into place, you'll notice at that point, the walls are already up and you'll see the footing here is already in place. So the footing's poured first, then your walls are placed. Now, technically, according to my research, I don't know if this is done around here or not, but according to my research, sometimes they can pour the footing and the walls in one pour, but typically it seems to be done in two pours. So the footing goes in and then the walls go up. And then after those are in place, then we do our floor, okay? So, well, how do we handle doing the floor? What are the things that we're going to need to know in order to figure out our volume? Well, one of the first things I want you to think about is where the concrete goes in comparison to the wall. Okay, think about the measurements that we have. So we've learned that when we have measurements on a blueprint, the measurement gives us the measurement of the building to the exterior of the wall. But take a look at your picture. The concrete for the floor is poured to the inside of the wall. So we're going to have to think about, well, how do we eliminate the concrete that's needed, the concrete that's not needed due to the wall being in place? So this is a great little diagram. It just highlights that our slab is poured last. So this is our slab, and you can see why it would be poured last because it actually rests on the foundation. And it's poured inside the walls, meaning if we used our standard measurements that use the exterior of the building, we would get a slab area and then a volume that would go right to the outside edge. Well, this section I'm highlighting in red is already filled in when we pour the wall. So we have to be able to figure out how do we remove that chunk. And it's really, really, really easy as long as you can calculate the centerline perimeter. So how do you calculate it? First of all, you're going to use the outside measurements. So the measurements given in the blueprint. You're going to find the overall area that the house takes up. Easy enough to do, especially if it's a rectangle. It won't always be a rectangle. So you'll find the overall area. We call that, I'll give you another word for that. We call this the gross area. Now, this time of year with doing taxes, the word gross is a word that I don't like to look at. When I look at my pay, especially at the end of the year, I see my gross pay. My gross pay is pay before deductions. I really do not like looking at the net pay, which is the pay after deductions. Comparing the gross pay and the net pay really sucks at tax time. Maybe you guys are better luck that way. So the gross area is the entire area. Then what we're going to find is we're going to subtract the wall area because we're not going to put concrete over the wall area. There's already concrete there. And then we get our basement floor area that excludes the wall. So that's just our measurement inside up to the dashed line. And we would call this our net. There's something going on here. Hopefully it's not because I'm doing a really late recording here. We call this the net area. Or we'll say the overall area. Okay, so just a couple words that you'll see come up. We've used the word gross before. Remember, we used that when we talked about siding. The gross area was the area that didn't subtract the windows. Then we found the net area after we subtracted windows. So we're using all of the same principles. Why do we need area? Well, if we know the area of the floor and the thickness of the floor, we can find our volume because we learned before that volume is going to be equal to the area times the thickness, Thickness. There we go. Times the thickness over which that area is consistent. Okay, so our floor, and in this case, this rectangle, it would be a rectangle all the way down. Okay, so we'll have some L shapes with a few funky shapes that we'll throw in, but exactly the same principles as before. So let's start with an example. I told you I'd start with an easy example. So in this example, we have our concrete floor. It says it's 90 thick, so all the measurements here are in millimeters, and we'll work in millimeters. And that might be a really good question for you for your assessment. It might be a question I'll have to add in, is to think about why would it be easier to calculate this using millimeters as opposed to when we have feet and inches, and then you have cubic yards? What are some challenges you would have if that was what I gave you for calculations? It's a very realistic calculation to give. It would be an excellent question to give you all the measurements in feet and inches and have to figure out how many cubic yards of concrete. You'll see that giving you everything in meters makes the questions easy. And I think you probably saw that in the last question. So first thing, notice everything's in millimeters, and you're going to be finding your volumes. I should have clarified in these questions. We're going to find everything in meters for this question. It doesn't make sense to do everything in millimeters. So meters squared for area. And then the basement concrete would be meters cubed. Okay. I did specify that in the practice worksheet, so you'll have that there. So because you want everything in meters, because it makes more sense to work in meters, let's go through and adjust our question. So it's just a matter of putting a decimal in place. So we get a decimal there, another decimal, oops, lost it. So that's the nice thing about working in metric. When we're working, this pen does not like to do decimals. It seems to think I'm doing some specialty feature. There we go, a little circle. So now, one of the biggest things to watch, this is a common mistake that gets made. People see 90 millimeters and they put 0.9 meters, but 90 millimeters is actually 0.09. We have to move that decimal 3 places. So there's your first common mistake that gets made if you want to make a list of the common mistakes that you can avoid. And then we'll put a decimal here as well. Okay, 0.2. So we've got everything switched to meters, and now we can calculate our centerline perimeter. So again, we're going back to that lesson 2 lessons ago. You need to review it, look at it. So it's always 2 times our length plus our width, because there's no jogs in this. So the normal formula for the perimeter of a rectangle minus 4 foundation thicknesses. Actually, I'm writing in, if I'm writing in letters, I might as well stick with letters for everything. So put that in there just so that you have the formula. Minus 4 thicknesses. And then as I calculate, it's going to be 2 times 8 plus 6 minus 4 times 0.2. If you put that in your calculator, you should find that that is equal to 27.2 meters. So that's our centerline perimeter. Now we know we can use centerline perimeter to find the area of the wall. So that's one of the things we're going to use to do. So the next thing says calculate basement wall area. So we're going to take our centerline perimeter. So 27.2. So that's the length of the wall times the width of the wall, which is 0.2. So 27.2 times 0.2 gives me 5.44 meters squared. Surprising how many square meters, like how large an area the walls would take if you could squish them all together. Now, gross area is the gross basement floor area. So using the outside measurements, what's the area? So we know the area of a rectangle is length times width. The length of this building is 8 meters. The width of it is 6 meters. So 8 times 6 leaves us with 48 meters squared. Now to find just the basement floor area, so this is only the floor, we're going to do gross minus wall. Okay, so the gross area, which is 48 meters squared, minus the wall area of 5.44 meters squared. That gives us a total of 42.56 meters squared. Now that we have that, then we multiply by how thick the floor is. Now, the thinner the floor, the smaller the volume we'll need. So you're going to find the number often will get quite small because we're going to be multiplying by decimals. The floor is never going to be a meter thick. It just doesn't make sense. And actually, one interesting thing from this is a few years ago, our house had a leak. So we had to put a sump pump in, and we weren't sure how deep, how thick the concrete was. My husband, he was like, I'm not sure. I said, I bet I can figure out the math, because I said, in all of the ILMs, it tells us that our slabs are between 90 and 120 millimeters thick. That's usually what's used. So able to use that, do a little bit of quick math, convert it to inches for him, and we knew how thick the floor was. We went and we cut it, and we were doing kind of smashing out the area to put in our sump pit and sump pump. That's exactly what we found. Just the 3 to 4 inch range was the thickness of the floor. So some of these things, even though you might even end up changing careers at some point, but some of those little things that stick with you, you go, oh, that's a basement floor is really not as thick as you think it is. So there's my interesting little, I say interesting to me, especially when it was a house we were selling. It was a really big deal to us because we had to make sure we could get that sump pump in and get everything all to stack on it. So, all right, so calculating the volume of the floor. So you take the area of the floor, and then we're going to multiply by how thick the floor is, which 0.090, that 90 millimeters is really close, just over 3 inches, between 3 and 4 inches thick. About 25 millimeters to an inch. So if I take 90 is close to 100, so that would be between 3 and 4 inches thick. Okay, so we're going to multiply those two together, and we find that we need 3.8 meters cubed. Okay, that's just for the floor. So pretty straightforward. We'll do another question. The next question, this question, we'll look at a common error. Really simple one to catch, but it's a common mistake that's made. So the first thing we're going to do in this question, just like every other question that uses a foundation, is we're going to find out what's the center line perimeter, because everything hinges on that. If you screw up the center line perimeter, the whole question's messed up. So in this question, we have a jog. So that means our formula is going to be 2 length plus width minus 4 thicknesses plus 2 times the length of the jog. Our jog length is the 3,400, not the 4,700. So that's really important for us to keep note of. We will need that 4,700 later, but not for calculating the center line perimeter. So to calculate the center line perimeter, we have 2 times, we have 10.4. You can go put the decimals in if you want. If you've got used enough to looking at them, you can just put the decimal in as you solve the question. Go ahead and do that. That's okay. That's actually a bit of a time saver. Use what makes you make less mistakes. So 10.4 plus 14.1 minus 4 times the wall thickness, 0.2, plus 2 times our jog, which is 3.4. If you put all of that into your calculator, keep your order of operations straight. That's going to be really important. You will get 55 meters. All right. So now that we have that, we need to find our wall area. Well, the wall area is easy, 55 meters. I take our perimeter times 0.2 meters. So the thickness of the wall. And that leaves us with 5. Oops, not 5. I'm jumping questions. You wonder how numbers change sometimes. When I do my keys up, I print 2 slides to a page, and sometimes your eye just catches the example in the slide before. So we have 11 meters squared. All right. Now we need the gross area. So the gross area uses exterior measurements. What is the area of the entire shaded space, the light and the dark? Now I'm going to just erase a highlight here because I think it's going to be helpful just to have that over the way. Okay, so how do we figure out the area? There's a couple ways to figure out the area of this particular object. One of the ways we could find the area is to break this into 3 sections. I could break it vertically, and I could figure out this rectangle plus this rectangle plus this rectangle. There's one method I could use. I could break it across horizontally, and I could figure out, well, what's this area? And what's the area of like the 2 squarish parts at the end? That's another way. I'm going to use a different method, and I think this method is actually a little easier. First, what we're going to do is we're going to find the area of the entire rectangle. So we're just going to treat this like it's one big rectangle. I'm sorry, but when you use this tablet outlining something to actually give you a full rectangle, it's difficult. Okay, so we're going to find basically what I outlined in red. Pretend that I did a good job. And then, so we're going to take area of big rectangle. And we're going to cut out what we don't need. So minus area cut out. Say area of jog, okay? You're going to take the whole area as if it was a rectangle, and then we're going to take the jog away. It makes for a lot easier calculations because we have less things we have to calculate. We can find the area of the large rectangle easy because we have the length and the width. So the large rectangle would be 10.4 times 14.1. And that gives us, if we put that in, 10.4 times 14.1 leaves us with 146 points. Let me see what's going on here. Apparently, I found out how to do subtitles. Oh, and I figured out how to do zooms. Don't write too close to the bottom of your screen is the moral of this story. I think escape will get me out. There we go. Excuse my clumsiness here. So 146 point. We'll see. Let's just go to eraser mode. We'll erase that and we're just going to move it because it's just going to be a pain. There we go. We'll put our pen back on and we'll just rearrange or rewrite. I can't be bothered fighting with that. I'll have to re-record if it gets much worse. So we have 146.64. Okay. Minus the area of the little jog. So that's the large rectangle. The smaller jog uses these lengths and widths. So this one's going to be 3.4 times 4.7. which leaves us with 25.16. So the gross area is going to be the large rectangle, which is 146.64, minus the little rectangle that's actually cut out, minus the jog. So 25.16 meters squared. And that happens to leave us with 121.48 meters squared. I'm keeping all the extra decimals because those extra decimals will come into play at the very end. So when you're doing your calculations, keep the extra decimals. It'll make life a little easier in SAM when you get your final answer. So now we need the basement floor area. So we're going to do the gross area, what we just calculated, 121.48. We're going to subtract the walls, which are 11, which leaves us with 110.48 meters squared. Now we're ready to find the basement floor concrete. So it's just going to be area of the floor. So we take the last step and we multiply it by the thickness. So 110.48 times the thickness. Note the thickness is 0.09 meters. That's that common mistake. So 0.09 meters leaves us with 9.94 cubic meters of concrete that are required. If you were going to round it, we'd round up to 10 because we want to make sure we have enough. You'd end up adding some waste in and some other factors there. So, all right, pretty straightforward. Now this question looks more challenging than it is. It's a pretty straightforward question, but you'll notice there's a lot of little shapes in this one. So the first thing we'll do is we'll find our centerline perimeter. Once you know the centerline perimeter, then we can easily calculate the area. We're just going to have to think about multiple shapes, that's all. So what we're going to do is we're going to figure out if this was a big rectangle, what would the area be? And then we're going to subtract a little bit. But first, centerline perimeter. So first of all, because I'm going to get probably too close to the edge here, I want to figure out what's the length of that side. So we're going to add these 4 measurements together. When you add them together, you will find the long side is 12.2 meters. Then we want to figure out, well, what's the total length along, you could say along the bottom or the top, whichever. So we want to figure out, well, what's this length up to the outside edge here, okay? What's that length? So you're going to add in, you're going to have to add 4.8, 4.2, 4.5. That takes us up to the outside edge. Those 3 measurements, we don't need this one. So you'll add those 3 measurements together and you should get 13.5 meters. Okay. Now that we have that, we can figure out our centerline perimeter. Now notice, there are no U shapes in this. They're kind of L cutouts on the corner. So this uses the no jog formula. So they're not actually considered jogs. So we're going to use 2 length plus width minus 4 thicknesses, which gives us 2 times 12.2 plus 13.5 minus 4. Our thickness this time is 0.25. Watch for those little numbers that change. There's often not very much variation in them in order to keep them realistic. And you will get a total area, or sorry, total areas, total perimeter of 50.4 meters. Okay. Straightforward to calculate. Now we want to find the basement wall area. 50.4 times the thickness of the wall, which is 0.25. Multiplying those together, we get 12.6 meters squared, the area taken up by the walls. Now the gross area of the floor. So the gross floor area is the area to the outside of the walls, but it does subtract the cutouts that we have on the corners. I always think of them as being cutouts. Okay, so this one's a little more tricky to calculate. So first, what I want to find out is the large rectangle. Okay, so the large rectangle, this includes everything. So we're going to find out the outside. So basically, if we could follow, this is even getting worse. I can't live with it, I'm sorry. I have to erase. If I get just the right angle, it's not too bad. So what we're doing is we're following, if there was a large rectangle that I have outlining the exterior, these exterior walls and basically everything that I have in red. So that's what I mean by the large rectangle. So what we're going to do is our length times our width. So we're going to do 12.2 times 13.5. 12.2 times 13.5 leaves us with 164.7. Now we're going to have to find areas of each of the small little sections that we can subtract from that number. So first of all, let's start with this one at the top. So we want to subtract this rectangle that I've just put a red X through. So we know that it is 2,500 millimeters high, or 2.5 meters in height. We need to find its length. Well, we can calculate that. 4.2 plus 4.5 leaves us with 8.7. So this area is going to be 8.7 times 2.5, which leaves us with 21.75 meters squared. All right, now we come down to this one. We have to take out this area as well. So this is what people often make mistakes in, is they forget to subtract some of the areas. So keep track of them, and an X through it can help you think of that area as excluded, so it has to be removed. So now this one, we're going to do 3.7 times 4.5. 3.7 times 4.5 will leave us with 16.65 meters squared. And then for the final one down here at the bottom, we have 6.8 times 2, which leaves us with 13.6. So we have all of our areas calculated. Now I'm going to go to the gross area box and I'm going to compile everything together. So what we're going to do is we start out with the big rectangle. So if there was no cutouts, it would be 164.7 minus the areas that are excluded, that we have the X's through. So we're going to subtract an area of 21.75. We're going to subtract another area of 16.65. And then we're going to finally subtract the lower right corner. I think we'll put left and right, which is 13.6. When you subtract all of those, you'll find the floor area is 112.7 meters squared. So that's your gross floor area. We still have the walls included in there. We haven't touched the walls. We got to subtract the walls still. So that's our next step, is subtract the walls to get the floor area. So 112.7 minus the wall area, which is 12.6, leaves us with 100.1 meters squared. And now we're down to the easy part, just finding the basement volume. So 100.1 meters squared times the floor thickness. This time it is 0.12. Move the decimal 3 places, 1, 2, 3, and it's decimal 0.12. So a little thicker floor in this particular example, and that leaves us with 12.0 meters cubed. And I did round to just 12. Now you could argue that I should round to maybe 12.1, because would you have enough? But take into consideration, you would add 5% extra. The 0.009 or 0.001%, I forget exactly what the number was without punching it in again, that came after that 0 that I just wrote, it would be accounted for in the 5% extra you would include. So for this example, it's fine. And you always have that tolerance, unless it specifically states in SAM, just to allow for some variation. So there's the 3 examples, the really straightforward examples. So there's just going to be one for you to do in SAM, but I am going to put a throwback volume question in just to take you back to some old stuff, just to have you do a quick refresh before you do your final assessment. So there'll be one question from an old quiz, and then you should be good to do your assessment for this section. And I should have the next section up within a couple of days. It's a really straightforward section. I do have it pre-recorded, but I want to go through it and re-record it for you. I think that would be helpful for me as well. So I'll get that posted for you shortly.